So in the preview question, which of the following is not congruent to 1? And so to figure out this question, we have to know what congruence means with respect to a modulus. So let's take one of these arithmetic problems and just sort of talk through it together. Let's say 5 times 5 mod 8. Okay. What do we mean if we're asking what is 5 times 5 mod 8? So what do you do to compute this quantity? Okay.
You sort of do the first math thing, so you get 25 first.
Okay, so you carry out the arithmetic as though these were integers.
And then the best way I learned, think of it, is you do elementary school division.
Okay.
So you'll divide that, or whatever you got for the arithmetic,
Mm-hmm.
by 8.
Yes.
But you're not doing long division, you're just getting the remainder.
Okay, so you do the
So
division.
3
25 divided by 8. 8 goes into 25 3 times, but it doesn't go in evenly. What's its remainder?
1.
Yeah, if we were to do the long division, that 1 would pop out right
And
here
you
at the
just
end.
look at the remainder.
Right? And then you just, when you're doing modular arithmetic, you take the remainder, and that remainder is your answer. And very often, in a lot of references, we're going to keep the mod 8 with this, right? So 25 and 1 are the same number mod 8, right? Because they both have the same remainder when we divide them by 8. So that's the short explanation for how modular arithmetic works, how to actually do arithmetic with a given modulus. Modular arithmetic is arithmetic of remainders. Why this thing should even be a well-defined thing to do, why we even get sensible arithmetic structures when we do modular arithmetic, well, that's a number theory question, and it's also an abstract algebra question. So we're going to, it turns out, do a lot of these kinds of calculations. Where is a place in everyday life that we do modular arithmetic? What's the classic example people use? There's a couple, probably, but there's one that's in this room. But yeah, that some of you are probably already glancing at because we only have 3 minutes left. Yeah, the clock. The clock is a natural place to do modular arithmetic. And so what's an example of a modular arithmetic calculation that you would do looking at a clock?
13.
Yeah, let's say it's 10 o'clock, right? Let's say it's 10 o'clock and I want to know what time is it 3 hours later. So 10 o'clock and I want to go 3 hours later, right?
10 plus 3 mod
10 plus 3 is 13, but on a clock, what's the modulus on a clock? What modulus do we use for the arithmetic on a clock? 12. Because 12 is the same thing as 0, which if you know military time, right, 0 hours is 12 o'clock midnight, 1200 hours is noon. On a regular 12-hour clock, those two are the same thing, right? So 12 is congruent to 0 is congruent to 24. And 13 modulo 12, so do the division. 12 goes into 13 once, and what's the remainder? 1. And that remainder tells me that it's 1 o'clock, right? 3 hours past 10.